Okay, let's hope that today does not take very long, because I don't want to spend very long on this. And I decided yesterday after deleting all my print statements, I was going to try and get logging to work in Python with like a flag that I can turn it on and off. So we'll see if I use that and if it works. The logging in Python never works for me. So day 12. Tried contacting the elves. The river is too low. Yes, I height map. Height map shows the local area from above broken into a grid. The elevation of each square of the grid is given by a single lowercase letter. A is the lowest elevation, B is next lowest, so up to the highest elevation. Also clear on the height map are marks for your current position S and the location that should get the best signal. Your current position S has elevation A. Location that should get the best signal has elevation Z. If you'd like to reach E but save energy, you should do it in as few steps as possible. During each step, you need to move exactly one square up, down, left, or right to avoid needing to get out your climbing gear. The elevation of the square can be at most one higher than the elevation. That is, if your current elevation is M, you can step to elevation N, but not to elevation O. It also means that the elevation destination square can be much lower. For example, okay, here you start in the top left corner. Your goal is near the middle. You could start by moving down or right, but eventually need to head towards the E at the bottom. From there, you can spiral around to the goal. In the above diagram, the symbols indicate whether the path exits each square, going up, down, the location of the best signal cell E, period marks towards the E at the bottom. This path reaches the goal. So let's see, it goes here, then it goes there, 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 then it goes there. What is the fewest steps required to move from your current position to the location that should get the best signal? Okay, so that seems relatively straightforward. Okay, so from string import ASCII lowercase. Okay, and we said S is the lowest heights. And so let's say cars equals S plus ASCII lowercase plus E. Wow, how did it know that? That's kind of interesting. And let's say heights equals CI for IC. Okay, so that's right too. And now from typing import, oh, I don't need to do that. And let's say grid equals list of strings. Okay. And no, I don't need that. And def parse, which takes raw to string to grid, return list line for line and raw split lines. Okay, that seems right too. Good. So and let's say find shortest path. Grid, which is a grid to an int. Okay. And we want to find the fewest steps. And for I row in grid, for JC in row, not grid, enumerates. For JC and enumerate row, if C equals S, I don't want to call it start, I'm going to call it pause equals IJ. And then we'll assume there's one S. I don't want to write I'd write a break, but I have to break out twice, it'd be a pain. Okay. And so, and now the other thing I need is I need a queue. So let's say from collections import dequeue. And let's say Q equals double-ended Q of pause and 0 steps. Okay, that seems right. Say pause equals -1, and let's just assert that we found it. Assert pause not equal to -1. Okay. Okay, so Q equals this. While Q, come on, you can do this. So this is wrong, but we'll start with it anyway. Pause steps equals Q pop left. IJ equals pause. If grid IJ equals E return steps, okay, that's fine. And let's do visited equals set. So we're going to keep track of where we visited to so that we don't go in circles. Visited.add pause. IJ equals pause. If grid IJ equals E, return steps. We could shortcut that by returning it when we find it, but that's fine. For DIDJ in this, new I, new J. Okay, I'm going to call them I2 and J2 just because that's shorter to type. Okay, and if I2 is less than 0, or I2 is bigger than or equal to grid, or J2 is less than 0, J2 is less than 0, then I just want to continue because that's off the thing. If I2, J2 and visited, I also want to continue. Otherwise, IJ equals pause, C, otherwise height equals heights grid IJ, that's good. If height grid I2, J2 is bigger than or equal to height, but what I want is it actually needs to be bigger than height plus 1, because I'm allowed to step up 1, right? Then I can continue as well. And then otherwise, Q append that, right? And so why does it not like this? Q append. Argument of type tuple, int cannot be assigned a parameter x of type tuple, literal 1, or tuple int, literal 0. Python typing Q. Let's see if we got that. What is the correct way to type int? Python typing deck directly. Okay, so from typing import tuple, and let's call this Q is a deck of a tuple int and an int. I typed it wrong. Okay, now that solved this problem. I should not have had that problem. That's something irritating that I don't know why Python does it. It's because types in Python suck. Okay, and then raise value error, no path found. Let's say grid equals parse raw, print find shortest path grid. So let's see if that works. And a12.pi, so that says 31. Was that the answer that they gave us? This path reaches the goal in 31 steps. Okay, good. So that's right. I'm pretty good at writing pathfinding algorithms for this kind of thing, because they do it every year. Okay, so assert that find shortest path grid equals 31. And now let's say with open day 12.text is f, grid equals parse f.read, print find shortest path grid. Okay, so let us run that. It's taking a long time. Why is it taking so long? It should not take so long. Okay, I did something wrong because let me look. Pop left. Visited add pause. Id equals pause. If there's otherwise heights equals that. For didj in that, I didn't read this part carefully, but I think that's right. I2 continue. If if that's visited, continue. If heights is too high, continue. Otherwise, append I2, J2 steps plus 1. So let's say logger.debug pause steps. I don't even know if that'll work. Whoa. Okay, so much for my print pause steps. So much for my idea to do debugging. I feel like I'm seeing duplicates. I am seeing duplicates. So why am I seeing duplicates? Let me do it this way. And then let's say visited.add I2, J2. Okay, now let's try this again. Value error, no path found. Okay, so at least it died faster that time. Set and pause, print pause steps. Let's try that one more time. Okay, so from 0, 0, I add there, 0, 0, I add there, 1, 1, 1, 1, 1, 1. Let's see, what did I do wrong? Visit equals set pause. Equals pause, height equals height grid for DIGJ. Visited, add that. If I2, let me do this as well. Oh, so then that should be the issue. All right, 412. I was not filtering things fast enough. So let's go to part 2. So I can tell it's also turn this to hiking trails, the better starting point. To maximize exercise while hiking, the trail should start as low as possible at elevation A. The goal is still the square mark D, however the trail should still be directing the fewest steps. So you need to find the shortest path from any square at elevation A to the square marked E. Again, consider the example from above. Now there are 6 choices for starting position. If you start at the bottom left square, you can reach the goal most quickly. This path reaches the goal in only 29 steps, the fewest possible. What is the fewest steps from any square with elevation A to the location that should get the best signal? Okay. So I'm going to just rewrite this, which I'm not happy about, but it will work better if I do. Find shortest path from an A. And now let's say A pause equals IJ for I row in enumerate grid, for JC in enumerate row, if C equals A. Good. Okay, so first I find all the A's. Then what I want to do, and actually start tuple int equals none. Right. And let me do this. Pause. If pause is not none, oh, come on. All right. I hate doing this, but if pause equals that, okay. So now let me run this again, just make sure that I didn't break it. Okay. All right, find shortest path from an A. And let's say so far, which is going to be a dict from a tuple of int to an int is that. So keep track of the shortest path from each A. And why am I going to do that? Is as follows. For pause in A pause, okay, so new queue, new visited, while the queue, pause steps, ij equals pause. If ij equals E, then so far pause equals steps, and then I want to break out of the while. Okay. And now otherwise, height equals height grid ij. Otherwise, if ij in so far pause equals steps plus so far ij, and then break out of the while. This way I'm not retracing my work all the time. It might not even be necessary, but I'm going to do it anyway. So now So that seems good. And for pause and a pause. Break, break. And then this is the good old trick, else raise value error. So if we break out, I won't hit this else, but if I don't break out, that means I never found anything. And now I want to return the min of so far.values. And so assert that find shortest path from an A grid equals 29. So let's try that and see if it works. I probably screwed something up. Oh, good. Print find shortest path from an A grid. Okay, so that didn't work. Raise value error, no path found. Let's see, print so far, print pause. Let's see how far it gets. Okay, so whatever I'm adding to so far, if grid ij equals e, okay, print pause steps q. So let's see that. That's a lot of printing. So let me not do that and say, let me go back to the previous one. Okay, so starting at 0, 1, which is A, 1, 0. Wait, 0, 1 is not A. 2, 5, 30. I'm using pause for two different things. That is the problem. Start pause. So far, that is the problem, I think. Okay, so now that didn't work. Is 30. Okay, well that's okay, that's fine. Print start pause so far. Okay, I think that will help me work it out. So 0, 1, 1, 0, 30, 32, 33, 34. And plus the square marked S that counts as being at elevation A. S counts as being as elevation A. S has elevation A and E has elevation Z. Oh, well, that's part of the problem too then, because I screwed this up from the beginning, and I'm surprised I got part one. Heights equals IC for C in enumerate. ASCII lowercase, and then let's say heights S equals heights A, and heights E equals heights Z. Okay, so that's one thing that I did wrong. And now let me run this again. And it's still wrong. So let's make sure that I've found all these things correctly. So my APOS are 0, 1, 1, 0, 2, 0, 3, 0, 4, 0. And because I didn't check that, or C equals E. I still got it wrong, but now let's see what I got wrong. Start at the bottom left square. So 4, 0, it's calling that 35, but all right, well, let me check because I start there. Okay. If start pause equals 4, 0. So let's just make sure that I understand what this is doing. 4, 0, 0, deck, nothing. 3, 0, deck, 4, 1, 1. Okay. Got it. I know what I did wrong. I know what I did wrong. Okay. And so best so far equals okay. So got to beat this. And let us say otherwise, if ij is in so far, and What happens if I just take this out and run it? It probably won't finish. Why did that break? Wait, that is 29. Why is that? Find shortest path from it, A. Something weird of sorts. 250. Why is 250? That can't be right. Start at 2.5. Oh, because it's not E, it's S. God, I'm an idiot. All right. Find. Okay, let's try this one more time. What? Let me take out some of these print statements because, again, they're too much. Okay, so that worked, that worked, that worked. So now, let me do this and see what's going wrong. You know what? No path found is okay. I don't need to do this because there will be some that there are no paths found from, right? Let me take out this, and there's something else that I'm printing. What am I printing? And let's make sure that there was a 412 in there. So let's make sure that 412, well, whatever, 402. I'll try it. That's the right answer. Okay, so a couple things. One, this is a standard breadth first search, so that part I got right. Two, I did a premature optimization where I was trying to say if you get to somewhere you've seen before, then reuse its result. Um, I did that wrong. What I should have done is said if you get that and that plus, well, what I should have done is I should have added it with a, if I was using a priority queue, anyway, I didn't need to do that. And when I tried to do it, I did it wrong. And so that screwed me up. Then I made another dumb mistake where I did this, um, put an E instead of an S. So that was stupid. And then I did another dumb mistake where I didn't read this and I set these to like one below and one above when they should have been equal. But like, if I don't make stupid mistakes and I don't misread the problem, it's actually not that bad. So um, yeah, cool. All right. I think that's it.